All right, welcome back into this, our lecture on subqueries. Now, before we start looking at subqueries, I'm going to give you my bias. I don't like these things. I don't like them because when improperly used, they can kill the performance of a database. Picture this scenario, and we've got 1,000 users on our database. We've got 500 tables, and if my experience tells me anything, 80 or 90% of the activity will be on half a dozen, maybe 10, 15 max of those 500 tables. So we have 500 or 1,000 people pounding on 2-3% of the tables in our database. The rest are there for reporting and exception handling and stuff like that, but generally they don't get beat up. It's the performance on those 10 or 20 tables that is going to make or break it for you as a database designer and you as a programmer onto that database. You write a bad query, i.e. a correlated subquery that brings back multiple rows, you can stop that database, and now 999 other people are stuck in the water and customer service starting to get calls. If that sounds like the voice of negative reinforcement and bad experience, it is. That being said, we're going to study subqueries because it's important that you know this stuff, both from a certification exam standpoint, but as well as a day-to-day writing code standpoint. You will encounter situations where you need to write subqueries. My only question or my only request is that you do so in a responsible fashion. To that end, really 4 types of subqueries, 3 of which are not problematic. Correlated and uncorrelated. Correlated simply means the inner and outer tables join. Uncorrelated, they don't. Single and multi-row. Single row is self-defining, multi-row is self-defining, and there's a variant on each with correlated and uncorrelated. Uncorrelated single row. I'm returning a single row once and handing it to the outer query, no performance problem. Single row correlated. Correlated subqueries need to execute one time for every row in the outer query. You got 5,000 rows in the outer query, you conduct an additional 5,000 queries with the subquery in a correlated single row. Uncorrelated multi-row. Not that bad because you're only executing the subquery once, returning that data set to the external query, and now you're moving along just fine again. Correlated multi-row subquery. Correlated subqueries execute one time for each row in the outer query. Example, I've got 5,000 rows in the external query, and the internal query returns 2,000 rows. I just returned 10 million rows to memory. Do you think I just created a performance problem associated with those 1,000 users? You better darn well believe it. Okay, that being said, we're going to learn about subqueries, but we're going to learn to do it in a responsible fashion. Let's get started by opening up lecture 15 selects.txt and my developer under the my store username. All right, let's go.
Okay, we're going to start with a perfectly safe subquery. Single row, uncorrelated subquery in the where clause of the outer query. No problem at all here with me. Perfectly fine with respect to performance. So let's check this out. Select product name as name, to-car suggested price template as price from products, or suggested price greater than or equal to, okay, here's our subquery. Select the average suggested price from product. Let's think it through. Looks like the subquery is going to go out to the products table and bring back for us the average suggested price of all products. The outer query then looks like it's going to return the name and suggested price of all products with a suggested price greater than or equal to that average returned by the subquery. All right, I can see where that'd be useful. I want to see all products whose price is greater than the average suggested price. You know, I'm thinking before we get started here, I'm going to run a select star on the products table because I don't remember exactly all what we have in there. All right, looks like we've got 5 rows with a suggested price ranging from $3.99 to $24. While we're at it, let's just run that subquery by itself to see what it returns. All right, looks like our average suggested price is $8.792. Fine, now we can safely run our full query expecting just the one row back as associated with the product with a suggested price of 24. Science, a beautiful thing when it works as expected. We got back just the one row at a suggested price of 24. Very cool. All right, that went so well. Let's try another single row uncorrelated subquery, but this time let's put it in the halving clause. Now, we haven't technically specifically studied the halving clause, but suffice it to say that it's the equivalent of a where clause on the group by clause. Basically, it allows you to further specify which rows will be included in a grouping. Don't worry, guys. A quick example here and you'll be a pro. All right, select first name, concatenate. Last name is customer and count from customers, interjoin orders using customer ID, interjoin outer order line items, C using order ID, group by A first name, A last name. And here's our halving, the count greater than or equal to our subquery. Select the average count from orders, interjoin order line items using order ID, group by customer ID. All right, let's think this through. What is this subquery giving us? Well, it looks like we are asking how many differing line items has each customer ordered, and then what's the average of that count. Apparently the value is 6, which makes perfect sense if you just check out the individual rows. All right, now let's consider the outer query. Looks like we are just getting the customer's name and number of line items that they ordered if their count is greater than the average. Well, we just looked at those individual counts and saw 2 customers with values of 10. I'll bet that's our result set. Ta-da! Our heavy drinkers, Jeff and David, just as we expected. Again, isn't science wonderful when it works properly? Okay, a special warning on this next example because I think it's particularly distasteful. I only include it because I know these inline views are included in the Oracle certification exams. Why, I have no idea. This is an inline view, i.e. a from clause which includes a subquery. I will just let you read it to study the syntax because I think it is just a terrible way to write this query. Did you also notice that I had to go back to the non-ANSI join methodology because I wasn't able to get this thing to work with standard ANSI joins? Anyway, basically it's using an inline view to retrieve the product name from the products table. Sure, it works, as testified by the results, but this is the better way to write that same query. Just include the products as another regular equal join table and don't bother using an inline view. Here's my last words on inline views. I have only seen one person try to use these and they ended up in my office asking me how to get the syntax correct. Net. He was basically trying to combine apples and oranges into a single, really stupid query. Better method. Run 2 queries if the scale and or the contents of the 2 sets vary significantly. Don't try to add apples to oranges. Leave inline views to this Oracle certification tests, but don't use them in regular practice. All right, we're going to start picking up the pace here a little as we're going back to the where clause subqueries, but now we're going into the realm of the more dangerous multi-row subqueries. We'll start with the less dangerous of the pair, uncorrelated multi-row subqueries. Remember, these uncorrelated subqueries are only executed once, and then that data set is passed back to the outer query for analysis. Let's jump right to the chase. Select first name, concatenate last name as multiple address customers from customers where customer ID is in Oh, it's a nasty operator. Select customer ID from customer addresses. Group by customer ID having count greater than 1. Looks like all the magic here is with this in keyword. Remember when we saw it previously, we used it in the check against values in a comma separated list. Well, really the same thing is happening here, except this time that list is being generated by a subquery. By the way, any and all operators also work the same way. Okay, on first look, I'm thinking this subquery returns all customer IDs associated with more than one customer address record. Remember, our having definition basically restricts rows on the grouping clause. Cool, just what the outer query column alias suggests. Oh, by the way, did you notice how to add a space to a column alias? Yeah, straightforward, double quotes. Maybe we better run this little query first just to see what we're dealing with. Yeah, 5 customer address records and 2 for Jeff Seymour. All right, we know what to expect now. Let's run our subquery and verify our expectations. Looks like a beautiful day in the neighborhood because there's only one row for Jeff Seymour. Uncorrelated multi-row subquery success. All right, moving on to correlated multi-row subqueries. We'll start with a pretty safe one, the exists operator. Select a first name concat a dot last name as subordinate from employees where exists subquery select one from employees B where B dot employee ID equals A dot manager ID. This subquery is correlated because the inner and outer tables are being joined over, in this case, B.employee ID equals A.manager ID. This means that the subquery is executed for each row returned by the outer query. Obviously, potentially very dangerous. In this case, though, not as bad because we're only doing an existence check. If any rows are found in the subquery, the outer condition will just be true. Net, as soon as the subquery finds a first row, it can stop executing. What do you expect with this subquery? Well, looks like we are looking for all people who have a manager who is also an employee, i.e. a subordinate. If you will recall from our data, I was manager to everyone except myself. Ta-da! The results as was expected. Okay, I just said that the exists operator can stop executing the subquery as soon as it finds a single record because at that point the conditional is deterministic. What about the in operator or the not exists operator? Nope. Those guys have to always completely realize the subquery data set before they can establish the conditional. Again, what if the outer data set had 5K rows and the inner 2K rows? Boom! Database performance just went in the tank. Net, do not run these subqueries on my shared database and kill performance. Test them first on your local box.
All right, that was good fun. I hope you learned a lot about subqueries because, as I suggested, they are important both with respect to day-to-day programming and, unfortunately, they're heavily emphasized in the certification exams. I'm not really sure why, but in any case, they are. What did we learn? First, we learned about simple single-row uncorrelated subquery. Give me the average or the min or the max in the subquery and then do some comparison against it in the outer query. Very straightforward, very easy. Never going to kill your box, so life is all good. Next, we learned about moving that same type of single row uncorrelated to the from clause. Dumb. Inline view. I've never seen any utility for it. Quite frankly, I think it probably evolved out of the academic nature of the ANSI standards, but in day-to-day practice, if you figure out a way that these should be used, shoot me an email because I'd actually appreciate a good example. In that same little section, we looked at putting a single row uncorrelated in the having clause. really nothing more than an extension of what we learned in the where clause, because the having clause is the parallel to the where clause, but as applied to the group by clause. So once you know one, you know the other. We then took a look at multi-row uncorrelated subqueries. Pretty useful, actually. I'm used to using them with an exists conditional operator in the outer clause, in which case you're basically looking for the first occurrence of a row in the subquery, and that makes that outer condition true. Common practice is in the subquery to select one to indicate that that's in fact what you're looking for. You're looking for one row to make that conditional true. Be very careful though when that query turns over to an any or an all not exists. We're getting into potentially problematic areas there, because that subquery could return a vast number of rows, in which case you got a big problem. We concluded with correlated multi-row subqueries. I have absolutely no problem with these when they are required, and sometimes they are. All I'm asking is that be careful with these guys, because they are desperately dangerous, particularly when you use any operator other than the exists, because you can all of a sudden stop a production database. All right, enough on forewarnings with respect to correlated multi-rows. They can and will kill your design. More queries in our next one, where we start looking at set operators, which are kind of cool and do actually apply sometimes to mixing apples and oranges, as well as the translate and decode function, because they are use them all the time kind of thing, so that'll be important. Looking forward to seeing you in the next lecture. In the interim, go out there, have some fun, but as I always say, remember to learn something every day.